Let's get right down to business, and we'll use this equation to illustrate the steps of a stoichiometric calculation. This reaction between iron 3 oxide and carbon yields iron and carbon monoxide. The first thing you absolutely have to do is balance the equation. If I don't balance the equation, this is all for naught. So let's do that right now. I put the proper coefficients in front of each of the substances in this reaction. Notice I put a 1 in front of the iron 3 oxide. That's just to help us remember that there's 1 iron 3 oxide for each of the other substances in this reaction. Suppose I'm asked to find how many moles of iron I'll produce from 150 grams of iron 3 oxide. First, I'll take the mass of my iron 3 oxide and convert it to moles by dividing by the molar mass. This conversion factor written in red represents that step for me. Notice that I have it arranged such that I'll end up dividing by the molar mass. I've also arranged it this way so that my units for grams will cancel. That leaves me with moles of iron 3 oxide. My next step is to determine the number of moles of the desired substance or the unknown substance using my mole ratios, mole to mole conversion. What's the relationship between iron 3 oxide and the iron? It's a 2-to-1 relationship. I get 2 moles of iron for every 1 mole of iron 3 oxide. Now I'm saying it that way on purpose. I want the moles of my desired substance on top and the moles of my known substance on the bottom. This is the stuff I'm trying to find. This is stuff I'm getting rid of. Again, notice that when I arrange it this way, I'm able to cancel the units for moles. Moles of iron 3 oxide, that is, leaving me with moles of iron. And that's what I've been asked to find, number of moles of iron. I can multiply all my numerators together and divide by all my denominators and get 1.88 moles of iron. That's how much iron will be produced from 150 grams of iron 3 oxide. But you know what? A lot of times they're not going to ask you for the moles, they're going to ask you for how much mass you're going to produce. After all, people think in terms of mass more than they do moles. So let's add one more step, and that step is to determine the mass of the unknown substance by multiplying by the molar mass of that substance. Here we have the number of moles of iron. We just need one more step, and that's to multiply by the molar mass of iron. This conversion factor represents that final step for me. Multiplying my moles of known by the molar mass will give me my final mass in grams. Notice that the units for moles of iron cancel, and I'm left with grams of iron. When I do the math, I need to do it this way. 150 times 2 times 55.8 divided by 159.6. That will give me an answer of 104.8 grams, or we'll call it 105 grams of iron. So in this reaction, 105 grams of iron will come from 150 grams of iron 3 oxide. Let's review our steps. We start with a balanced equation. That's an absolute must. Next, we converted the mass of the substance we know into moles. We did this by dividing by the molar mass. Then, we found the moles of the substance we want, that is the unknown substance, by using the mole relationships we find in the reaction, the coefficients in front of each of the substances. In this case, it was a 2-to-1 relationship. Remember to arrange it so that the substance that you want is on top, the substance that you're getting rid of is on the bottom. Finally, we converted to mass of the desired substance by multiplying by the molar mass of that substance. Now, as you saw previously, sometimes you won't have to use all the steps that we've just listed. Before, when I asked about moles of iron, that only took you to step 3, didn't it? We didn't have to do step 4. What if they ask you for moles and you were already given moles? You wouldn't even have to do step 2, would you? All you'd have to do is step 3 to get to your answer. Do you see what I mean? It's important to recognize which steps you'll actually use. I want to show you an alternative way of solving what we call mass-to-mass stoichiometric calculations. In other words, taking the mass of a known and solving for the mass of an unknown. The previous way we did it was using those 4 steps, having conversion factors and solving in that fashion. But this way is actually called the magic number method, and it's a little bit more of an algebraic way of solving. I start by having my balanced equation. I must have a balanced equation to do any type of stoichiometric calculation. Next, I'm going to place an X in front of each of the substances. I'll then write the molar mass in front of each of the substances. That'll do it for me. The molar mass of iron 3 oxide is 159.6. The molar mass of carbon is 12. The molar mass of iron is 55.8. And the molar mass of carbon monoxide is 28. Now, I'll multiply together everything in front of each of the substances, like this. 159.6 times X times 1 gives me 159.6X. 12 times X times 3 gives me 36X. 55.8 times 2 times X gives me 111.6X. Finally, 28 times 3 times X gives me 84X. In this case, I don't even need to worry really about carbon and carbon monoxide. They're not a part of my calculation, just iron 3 oxide and iron. What I do next is I equate 159.6X to the amount that they gave me. So 159.6X equals 150. And I solve for X. So X equals 150 divided by 159.6. X equals 0.940. All I do now is I take this number and I plug it in there for the value of X. So 111.6 times 0.940 gives me 104.9 or 105 grams of iron. If that number looks familiar, it should. It's the exact same number we got when we used the 4 stoichiometric steps previously. But I need to say again, this is important. You're only able to use this when you're going from mass to mass. If you're going from moles to mass or mass to moles or moles to moles for that matter, you can't use the magic number method. You'll have to use the appropriate steps that we talked about previously. All right, here's a problem for you to do. Here's the reaction between sulfur tetrafluoride and water that produces sulfur dioxide and hydrofluoric acid. If I have 20 grams of sulfur tetrafluoride, how many grams of water will I need to completely use up that 20 grams? Now, don't freak out about this. We're doing the same things we did before. Here's your known, this is your unknown. It doesn't matter if it's a product or a reactant. The same rules apply. Okay? So give it a try. You can use the steps or use the magic number method and see if you can come up with the proper answer. You can put your answers in the LMS. That's all the time we have for this video. Today we talked about how we can make stoichiometric calculations, either using steps to do it or the magic number method. Remember that the magic number method only works for mass to mass conversions. In other words, taking the mass of a known substance and converting to a mass of an unknown substance. Otherwise, we'll have to use 1 or 2 of these stoichiometry steps we talked about. If you have any questions about this or have any problems understanding, please don't hesitate to let me know. Give me an email or reach out to me. I'll be glad to help. Until next time, God bless.